a lot of the problems you were solving yesterday were just plain sort of velocity acceleration questions. So let's take a look at one of these particular problems or a problem like it. So here if we have Paul riding a skateboard on a frictionless flat surface, remember this is physics world, so Paul couldn't get going at 1.75 meters per second if it was completely frictionless. But we say he has a headwind that starts pushing back on him at 0.25 meters per second every second. And so we want to know how fast he'll be moving after 5 seconds. All right, so if we take a look at our kinematic equations, probably the easiest one to use here would be this guy, Vf equals Vi plus A delta T. Okay, and if we use that equation, then we can kind of plug in information from the problem, and that'll help us. All right, so the first thing we want to know is how fast he'll be moving after 5 seconds. We have to think, well, which one is that? Well, if we look at 5 seconds, how fast, or how fast that will be. So that's going to be our VF right there. Okay, our initial velocity. Well, is how fast Paul was going when he started out. So in this case, it's just the 1.75 meters per second. So we'll put that right there. Okay, now, his acceleration. If we watch the units there, you can notice that the acceleration is going to be the meters per second every second, because that's a change in his velocity. But we also have to recognize the directionality of that. Remember, it's a vector, and so it's pushing him backwards. So that's going to be a negative 0.25 meters per second every second. So that's how much it's slowing him down every second. And then if he does that for a total time, if we take that and do it, okay, for a total time of 5 seconds, we'll know how fast he's going after 5 seconds. All right. So if we do the math on this, let's take these terms over here, that A delta T first, and if we multiply those together, okay, we can do that and come out with a negative 1.25. And if we look at seconds canceling seconds, you'll notice that that's going to be an answer in meters per second. And then if we bring down our 1.75, notice that's also in meters per second, our initial velocity. And if we add those together, then we can come up with our final solution of 0.50 meters per second, because we're going to keep the same units. And that would be our solution. Now remember that that value is a vector. It is in the positive direction. So Paul's going to have slowed down from 1.75 meters per second when he started, and after this headwind of 5 seconds, he's only going to be going 0.5 meters per second. Now, he might want to push again to get going a little faster, but remember it's a frictionless surface, so he could have some trouble with that. But hey, it's physics world. All right, I hope that helps. Thanks, guys. Bye.